Hello, my name is Chijoke Franklin Emeju, and I will be presenting my research project on optimizing fraudulent transaction detection in e-commerce, a comparative analysis of machine learning and deep learning algorithms with time and CPU performance tracking under the supervision of Joel Aleboro. Introduction. With the rise of the online payments in e-commerce platforms, cybercriminals have learned to take advantage of unknowing customers. Online shopping and payments are becoming more popular, but this also means more opportunities for cybercriminals to cheat people and steal money. Old methods of detecting fraud are no longer effective because fraudsters are becoming smarter. To solve this problem, businesses are using new technologies like machine learning. These tools can quickly analyze large amounts of data, identify unusual patterns, and adapt to new threats, making them better at detecting and preventing fraud. Aim and objectives. This thesis aims to improve e-commerce fraud detection by optimizing machine learning models for accuracy and efficiency. It compares algorithms, analyzes resource usage, and identifies trade-off to recommend the best approach for practical fraud detection system. The research question: which machine learning and deep learning models offer the highest accuracy in detection of fraudulent activities in e-commerce? Machine learning models like gradient boosting and deep learning models such as multi-layer perceptions deliver higher accuracy for detecting fraudulent transactions. Computational efficiency can be improved by simplifying models, optimizing algorithms, and using hardware accelerators without significantly compromising accuracy. And gradient boosting often strikes the best balance between accuracy, speed, and CPU usage, making it a practical choice for scalable fraud detection systems in e-commerce. While deep learning models can offer high accuracy, they may require more resources, so they are best suited for cases where resource availability is not a limitation. Limitations. The following limitations were encountered when implementing the research process. Um, when building a fraud detection system, using data and machine learning, several limitations can arise. First, the effectiveness of the model depends on the availability and quality of historical transaction data. So, limited access to good data can reduce the model's performance and ability to generalize. The literature survey. This literature review examines the use of machine learning in detecting fraudulent transactions, particularly in financial institutions. Financial institutions. It highlights the application of supervised learning methods like decision trees and support vector machines, which can face issues such as class imbalance and overfitting. Deep learning models such as octo encoders have also been explored for fraud detection with mixed results, showing both advantages and limitations. Unsupervised learning approaches, including anomaly detection, can gaining attention but may not always provide reliable results. The review emphasizes the need for more advanced and balanced methods to improve fraud detection system in real-world application. And this is the methodology, design, implementation, and specifications, data sets. The methodology includes several steps such as research, data collection, data processing, feature selection, model selection, training and evaluation. Uh, Also, various machine learning algorithms were explored, including logistic regression, random forest, gradient boosting, XGBoost, decision tree, support vector machine, and artificial neural networks. The goal was to optimize accuracy, precision, and computational efficiency in detecting fraudulent transactions. The system's durability and performance were ensured through careful model selection and evaluation. And the data evaluation. This study compared 7 machine learning models to detect and classify online fraudulent activities. The models were tested on a balanced data set to ensure accuracy. Random forest, XGBoost, and gradient boosting performed best with high accuracy and precision. The multi-layer perception also shows strong performance. The study found that the data balancing and model selection are important for effective fraud detection. The result can help improve online fraud detection systems. And moving over the um, to the code implementation, to the code implementation. So I started by importing the libraries that I use through the entire project. And here are the libraries. Then reading the data set. I read the data set and visualized the data sets. Um, and this is the data processing. I looked at the unique values because one needs to understand the data set very well to know which column needs to be encoded, which column needs to be dropped, which column has numerical value, and which column has string values like this here. Um, data exploratory data analysis. This is the exploratory data analysis, and the analysis here are, are self-explanatory. They are all self-explanatory. Then dropping of redundant columns. This is the drop of redundant column, just like this. Timestamp, sending address, and receiving address. And if you look at the read data set here, it has timestamp, sending address, receiving address, and amount. You will see that they are useless for the training because I'm not doing blockchain, so I don't need all those things here, and that's why they were dropped here. That's why they were dropped here in the dropping of redundant columns. Label encoder, and this is the label encoder. So after dropping them, I have to label and encode the dataset, which is what I did here. Label encoder is just like converting your nominal variables to your categorical variables so that we have a numeric 1 and 0 format, because that is what the machine learning needs. And this is applying the random sampler. And this random sampler that samples the imbalanced data, make it balanced. The data, the next is to train the models. This is just straightforward. Because all you have to do is just to call the machine learning algorithms and fix the train and the test sets. This is the multi-layer perception. Multi-layer perception. So for deep learning, one needs to know the artificial neural network with different layers. Just like of neurons, like a normal human brain. Here I use TensorFlow, not Python. So and here is the model sequential. I created the model, and this is the model here. And this is model compilation. This is the training loop. So I had the accuracy of 98 percent here, 98%. So this is the model accuracy and model loss. This is the plot of the model accuracy and model loss because you are training your model. It has to increase from the blue, from this blue validation. You can see that they did not overfit. Just as my supervisor thought that it overfitted when he gave me a feedback. So the blue is going up, the red is going up as well, and the loss is going down here. And this is the final accuracy for the test, which is 98%. So in conclusion, of my project, this study used machine learning to detect fraudulent transaction in e-commerce. Seven models were detected, and the random forest model performed best, while the support vector machine performed worst. The study found that a simple model can outperform a complex deep learning model if the data is not suitable. And also, future work should focus on using more advanced techniques and real-time data to improve detection rates and increase transparency. This is the end of my presentation. Thank you.